Okay, so synthetic division, continuing on with our 2.4 notes. Synthetic division is just kind of an alternative method of long division. A method to divide a polynomial by a linear expression, like x minus 1. And then a couple notes about that. The leading coefficient must be 1 and a is a 0 of the divisor. So we're going to talk about that a little bit. When I'm doing long division, I could divide by things like 2a minus 3 or x squared plus 5. I can divide by anything that I want. When I'm doing synthetic division, it only works when the divisor is of this form, 1x plus or minus a number, that's it. So you don't have to know how to do synthetic division because you can get by always doing long division. But when we come to doing a lot of these problems and are checking for a lot of zeros, doing the whole process of long division becomes really tiresome because it's long, it's tedious, there's a lot of ways to make an error. So we have synthetic division to help us out. But synthetic division only works for some cases, so you still have to know long division. So we haven't talked a lot about zeros yet, but to give you a little information, if I have a factor like x minus 3, and that is a 0 of the function, that means that I would take that and I would set it equal to 0. And I'm just coming up with an example here. And then when I would solve for x, I would get x equals 3. So if I have a linear factor like x minus 3, that's a factor of some polynomial, then x equals 3 is what's called the 0 of the function. That means that when the function is 0, when y is 0, x can be 3. Just like before when I had long division, if I have any missing terms, I'm going to write those in. So if I were to rewrite this, I would have 2x cubed minus 7x squared. You'll notice I'm skipping the x term. So I'm going to write that in, just like we did with long division. Now this is going to feel a little weird as we do this. It's kind of more about rules because it's synthetic. I'm going to copy down the coefficients only. So the coefficients are the numbers in front of the variable. So I have the 2 and a negative 7 and a 0 and a negative 4. I'm going to copy those down in kind of a line over here. So 2, negative 7, 0, negative 4. The 0 of the function is a value of x when y is 0. So if I have x minus 3 as a factor, I'm dividing by this linear factor right here, but I want the value of x here. So I'm basically going to take the opposite. This is going to be 3 for the exact reasons that I did over here in purple. You also just take the opposite. Okay, so I'm going to go through this process. It's a little bit backwards from long division. So I'm going to drop down the first number. Give it a chance. You'll have to see this a couple times before it clicks. And then I'm going to multiply what's underneath the line by this 0 right here, this number that I'm testing. So I'm going to multiply 3 times 2 which gives me 6, and I write it in this spot here. So I multiply 3 times 2, which gives me the 6. And then I'm going to add down. -7 plus 6 is -1. So let me go over all this again so far. I copied down the coefficients from the polynomial. So coefficient of x cubed is 2, x squared is -7. I had a missing term, so I wrote that in. I have a coefficient of 0, and then a constant of -4. I want to divide by x minus 3. So I'm just going to put the actual value of 3 right here. When I start my process, I bring the 2 down. I bring the first term down. I multiply on a diagonal, and then I drop it in the next spot. So 3 times 2 is 6. Drop it here. Add down. I'm going to continue with this process with every new number I put here. So now I'm going to take the 3 times -1 and multiply and put it in this spot. So now I'm going to do 3 times -1, which is -3. And add down. 0 and -3 gives me -3. I have a new number on the bottom. I'm going to continue this process until I run out of things. So I have 3 times -3, and I'm going to write it in the next space. Which is -9. Add down. -4 and -9 is -13. When there's nothing, when there's no spaces left, and there's nothing more to keep going, then I'm done. That last thing is the remainder. If the remainder is 0, then it goes in evenly. So now I have to make sense of what I've got left. What I have left are the coefficients of what's called the depressed equation. I started with 2x cubed as my leading term, and I divided by x, which means I've lost an x, right? So my divisor is going to have a largest term of x squared. So this is going to be an x squared term, this is going to be an x, and this is going to be a number. It's going to be a constant. So my answer for this division problem is 2x squared minus 1x minus 3 with a remainder of negative 13. And I'm going to write that over my divisor, x minus 3. It's a new process, a little weird, a little strange. It almost feels like using a trick. But it'll get easier and faster as you do more. So again, how did I know this was 2x squared? Let's talk about it. I have 2x cubed. I have x cubed, and I'm dividing by x. So just like when we were doing our long division problems, scroll up to 1. Right here, I had x to the 4th. I divided by x, which means my result ended up starting with x cubed because I lost an x, which is going to be the same for all of these. Okay? So I started with x cubed. I divided by an x. So my next one was x squared because I lost an x. So that's how I know where to start here. I have x cubed. I divide by x. That means my first term has to be x squared. And then I just go down from there. They're all in standard form. X squared, x, the first constant, and then the remainder. Okay. Now that you've seen it once, roll through it again. So step 1, I'm going to copy down all the coefficients from my big polynomial. Let's see. 4, 14, negative 25, 26, and negative 4. This polynomial doesn't have any terms that I skip over, so I don't have to add in any 0 terms. My exponents are 4, 3, 2, 1, 0, so I'm good. I have to decide what number goes outside. So the thing I'm dividing by is x plus 5. But I want the value of x, so I'm going to set it equal to 0. Solve for x, and I get negative 5. That's what goes in the bubble. It's basically just the opposite of whatever I have going on with that divisor. Any questions that I can answer on the setup? How did I get the negative 5? How do I know those numbers? Do they have to go in that order? No, we're okay on the setup? Okay, cool. So step 1, I bring down the 4. When I do long division, I have to divide, subtract, divide, subtract, divide, subtract. Here, I'm going to multiply and add, multiply, add, multiply, add. So whatever number is next under the line is what I'm going to multiply by the number in the bubble. So negative 5 times 4 is negative 20. I'm going to write it here. So I multiply and then I add down. 14 negative 20 is negative 6. I multiply my new number times my number in the bubble. So negative 6 times negative 5 gives me a positive 30. Add down. Negative 25 and 30 gives me a 5. Negative 5 times 5 gives me a negative 25. And multiply here. Add down. 26 and negative 25 gives me 1. Negative 5 times 1 is negative 5. Add down, I get negative 9. The last number is always the remainder. I started with x to the 4th and I lost an x. So that means my biggest term here is going to be x cubed. And then I go down from there. X cubed, x squared, x, a number, and then a remainder. Writing this is not necessary. I just think it's helpful. So then my whole polynomial is going to be 4x cubed minus 6x squared plus 5x plus 1 minus 9 divided by x plus 5. I'm going to go out of order. No, I'm good at doing that. And I want to go down to D. And before I write it up there, go ahead and just try to do the setup for problem D. So 6x cubed plus 16x squared plus 3x minus 10 divided by x plus 2. We should probably have parentheses around these. We should definitely have parentheses around them. So go ahead and try to write the setup before I start. Okay, let's see how your setup looks. Let's see, I get a 6 and a 16 and a 3 and a negative 10. And then my number in the bubble should be negative 2. It's good? Cool. Okay. So I bring down the first term, which is 6. Multiply, add, multiply, add, multiply, add. Negative 2 times 6 gives me negative 12. Add down, I get 4. Then I take whatever new number I have and multiply that by what's in the bubble. So negative 2 times 4 is negative 8. Add down, I get negative 5. Negative 2 times negative 5 is a positive 10. Add down, I get 0. All right, we haven't had our last number be 0 yet. Remember that that's the remainder. Go ahead and try to write the final answer given that. See if you can write the quotient from that division problem. Okay, so if you wrote it down properly, you'd get 6x squared plus 4x minus 5, and that would be it. No remainder available. Feel pretty good? Easier than long division? Yes. Only works for some cases, though. All right, I'm going to give you problem C to do on your own. So from start to finish, give it a shot. If you did C correctly, you would have gotten a remainder of positive 8. So reminder about C is it is missing a term. The x squared term is missing, so if you didn't write that in, probably didn't work out for you. So when I write out my coefficients, I have 3, 0, negative 5, and 10. And the number in the bubble, the 0 that we're testing to see if it works, to see if it's a divisor, is 1. All right. Bring down the 3. 1 times 3 is 3. I add down, get 3. 1 times 3 is 3. I add down, I get negative 2. 1 times negative 2 is negative 2. Add down, I get 8. So final answer should be 3x squared plus 3x minus 2 plus 8 divided by the divisor x minus 1. Questions that I can answer on that before we move on? Not too bad. Okay. So something else we're talking about today is something called the remainder theorem. The remainder theorem is when a polynomial p of x is divided by x minus a. The remainder is p of a. It is a great way to check for a factor, but that's all it does. It only gives me the remainder. So I would recommend writing down that theorem, and then we'll do 2 example problems. Example 3, use the remainder theorem to evaluate each polynomial for the given value of x. Is the given x a 0 of the function? The math here is familiar. It's not difficult. It's just applying it and making new meaning out of it. problem A, f of x is equal to 2x to the fourth plus 6x cubed minus 5x squared minus 50. And I'm testing the 0, x equals negative 1. I'm testing the value. So all I'm going to do is I'm going to take negative 1 and I'm going to plug it in everywhere into my function for x. And then when I simplify all that, that number is the remainder. Now, can I find the remainder in other ways? Yes, you could do synthetic division or long division. This is another method. So I'm going to take and I'm going to evaluate f at negative 1. And I'm going to replace every x with negative 1. I have 2 times negative 1 to the power of 4 plus 6 times negative 1 to the power of 3 minus 5 times negative 1 squared minus 50. And I'm going to simplify everything on the right-hand side. Remember, f of negative 1 is just a notation. This is just saying I'm evaluating this function at negative 1. It's like directions. And the right-hand side is everything that I'm going to simplify. When I start simplifying, I always start with my order of operations. So I start inside parentheses. There's no operations inside these parentheses. They just hold numbers. So then I'm going to go to exponents. So I have negative 1 to the power of 4. Negative 1 times negative 1 times negative 1 times negative 1. When I have an even exponent, that simplifies to a positive 1. Negative 1 to the power of 3, and negative 1 times a negative 1 times a negative 1 is going to give me a negative 1. Negative 1 squared gives me a positive 1. And I keep simplifying. Two times 1 is 2, minus 6, minus 5, minus 50. And when I add all that together, I get negative 59. Now I know there's other ways to get the remainder. I could use synthetic division and find a remainder of negative 59. I could use long division and find a remainder of negative 59, but this also gives me the remainder. Now that's all it gives me, so it's not always that useful. But in some instances, it's very useful. So if I'm just checking to see if negative 1 is a 0 of the function, which is the second question here, is the given x a 0 of the function, then this is easy to just say yes or no, right? Since I have a remainder, I'm going to change my color here so that you can see it a little better. So the second part of the question, is the given x a 0 of the function? It's no, it's not a 0 because we have a remainder. we're learning 3 methods, which we're going to expand upon in our next section, to help us find factors and find zeros. Long division, synthetic division, and the remainder theorem. So for the remainder theorem, all you have to do is you have to plug in that value of x, see if you get 0 or something that's not 0. So go ahead and try problem B. 3x cubed plus 14x squared minus 13x minus 2. I think I goofed when I typed this. Because there's not an f of x there. It should look like that. Here you go. You'll see f of x a lot, and you'll see p of x a lot. It's the same meaning. So go ahead and find the remainder if the x value is 2 by just plugging 2 in for x. With any luck, you get 0. Hopefully. No? Uh-oh. Oh, you're right. It's not 0 because I copied the problem down wrong. Okay. I don't know what I get because in my old notes I got 0, but I wrote 13 instead of the number that I have on that paper. What do you get? 52? Perfect. All right. Well, that didn't work out as planned. If I got 0, that would mean that yes, it is a factor. Is that okay? All right. Must have been distracted while I was doing these notes and not double checking my work. All right. So 2 cubed gives me 8. 2 squared gives me 4. Let's see, that's 24 plus 56 minus 26 minus 2. Minus 2, minus 2, minus 4. Yeah, 52. Cool. Great. So I get f equals 52. And that means that no x equals 2 is not a factor. If we got 0, it would be a factor. And then example 4 will be our last example set. Just 2 more problems to go. Example 4, determine if the binomial is a factor of the polynomial. If it is, write the polynomial as a product of the 2 factors. So determine if the binomial is a factor of the polynomial. I know 3 ways to do that now. I could use long division, I could use synthetic division, and I could use the remainder theorem. But they give me different pieces of information sometimes. If I use long division, right, I could take x minus 6 and divide it into this whole thing. And at the end, I will get the result of the division, right? I'll get the quotient, including the remainder. If I use synthetic division, right, I can find the value of x that I'm testing, which is 6. I can use synthetic division, and I can also get the resulting polynomial and the remainder. If I use the remainder theorem, all I get is the remainder, and that only tells me if yes, it's a divisor, or no, it's not a divisor. So you have choices here, and there's not necessarily one way to do it. I have a suggestion for you, but you could do it any of these ways. You could use long division, or you could use synthetic division. If you choose to use remainder theorem, and you get a remainder of 0, then you would have to then go use either long division or synthetic division to find the rest of it. To me, that seems like extra work. I find synthetic division easy, so if you find it easy, I would say do synthetic division just right off the bat, instead of testing something and then doing it or not. If you prefer long division, you can use long division. It's kind of up to you. I would suggest using synthetic. But you have choices. Some people are like, there's no way I'm learning another kind of division. If long division works for me, I'm going to do it every time. Cool. You do you. Go for it. If you like the remainder theorem because it's easy, it might cause you less work or it might cause you more work. It's kind of a gamble. I like synthetic because I have to do one thing for this and it's done. So let's see. Coefficient of x to the 4th is 1. Coefficient of x cubed is negative 8. Coefficient is 16. Negative 23. Constant is negative 6. And I don't have any missing term, so that makes it nice. Now my divisor is x minus 6. What number do I use for synthetic division then? What goes in the bubble? Positive 6. Yes. So by doing synthetic division, it's going to tell me if it's a factor, and if it is, then I'll be able to write the polynomial. All right. So I bring down the 1, multiply and add all the way to the end. 6 times 1 gives me 6. Add down, I get negative 2. 6 times negative 2 gives me negative 12. Add down, I get 4. 6 times 4 is 24. Add down, I get 1. 6 times 1 is 6. Add down, I get 0. The 0 tells me, yes, it's a factor. So again, a two-part problem. Determine if the binomial is a factor of the polynomial. Yes, it is. You could also determine that using just the remainder theorem. But if it's a yes, then you have to do synthetic or long division after that because I need the result. So it says, if it is, write the polynomial as a product of two factors. Well, one of the factors is x minus 6, and the other factor is what I get left when I divide by x minus 6. So let's see, that's the remainder, this is my constant, this is x squared, and this is x cubed. So I have 1x cubed minus 2x squared plus 4x plus 1. That's the result when I divide by it. Remember, if it goes in evenly, yes, it's a factor. The factor that I divided by x minus 6 is included also. So I know that x minus 6 times x cubed minus 2x squared plus 4x plus 1 gives me this. Now you could verify that by multiplying it all out, but I don't really want to. You could. You could multiply all that out and get this. I'm going to relate that back to the very first thing we did in this unit. So I'm going to scroll away from the screen for just a second. I'll come back, I promise. When we were doing, it was a long ways up. When we were doing long division of numbers, and we said, okay, let's just do some long division. 8 goes in 184. And we found out, okay, when I have a remainder of 0, it goes in evenly 23 times. Well, now, that's true that because it goes in evenly, 23 times 8 is 184. So I'm writing this as a product of its factors. I'm doing the same thing now. I have a divisor 8, and I have the result with no remainder 23. I can write those as a multiplication to get the original number. So same thing down here. I have a whole polynomial. I'm dividing by some number, some expression, and I get something with no remainder. That means it goes in evenly. Therefore, x minus 6 is a factor, and I can take x minus 6 times the result, x cubed minus 2x squared plus 4x plus 1, to get what I originally started with. All right, last one. Go ahead and do synthetic division again for me there. Give you maybe a 2-minute head start. P of x is equal to x to the 5th minus 5x cubed plus 9x squared minus x plus 3. And I'm dividing by the binomial x plus 3. Feel free to talk about it with somebody next to you. You have that option. You're allowed to compare. Make sure you wrote in the missing term. Don't let it catch you off guard. When I do synthetic division, I got a remainder of negative 21. I know that if I have a remainder other than 0, then it's not a factor. So the 2 parts of the question says, determine if the binomial is a factor of the polynomial. It's not. If it is, write the polynomial as a product of 2 factors. Well, it's not, so I'm done. I don't even need to write the depressed equation. I only need it if it's a factor, and it's not a factor, so that's it. Cool? Okay. Okay, so that finally finishes 2.4 for us.